Let's begin. So it is given that it is an HP and the pth term is Q into P plus Q. So we know how to write an HP, right? It is 1 upon A plus, for the nth term it is n minus 1 into D. So over here it is given that the pth term is this. So let's just write 1 upon, we have A plus P minus 1 into D is equal to Q into P plus Q. And then the next thing is 1 upon A plus the qth term. So Q minus 1 into D is equal to, what is it? P into P plus Q. And first we have to prove that 1 upon A plus, so P plus Q term, so that is P plus Q minus 1 into D is equal to PQ. Okay, so first let's start with this. Now the x and the y equations, let's do a reciprocal of them and subtract, so that way we can eliminate A and we will get D. So this will become x minus y, so P minus Q into D is equal to, it will be 1 upon Q into P plus Q minus 1 upon P into P plus Q. So P plus Q is common, and inside we have 1 upon Q minus 1 upon P. So let's just write it as P minus Q upon PQ. Now P minus Q and P minus Q will cancel each other out, and finally we get D is equal to 1 upon P plus Q into PQ. Okay, now substitute this D in any one of the equations, x or y, and we will find out the value of A. So this will be the reciprocal of one of the equations, right? Let's take equation x. So the reciprocal of that is A plus P minus 1, and then D is P plus Q into PQ is equal to 1 upon Q plus P. Okay, so let's just multiply in the numerator and denominator by P and P. Therefore, P plus Q cancels out, P plus Q cancels out, PQ in the denominator, PQ in the denominator, and one of the P in the P in the numerator and P in the numerator on both sides. So we get A is equal to 1 upon, we are left with PQ into P plus Q. The cancelling out of this and this term was only for the term P. So we find that D and A are equal to each other. Now applying that in this equation, we can just cancel out A and minus 1D, right? So we are left with 1 upon P plus Q into D. So 1 upon P plus Q into D, and D is 1 upon P plus Q into PQ. So P plus Q will cancel out, denominator of denominator will go in the numerator. So this is equal to P into Q. So we have proved the first part of the problem. Now for the second part, we have to prove that 1 upon A plus PQ minus 1D is equal to P plus Q. Now similarly, A and D will cancel out and we are left with 1 upon PQD, and then D is equal to 1 upon P plus Q into PQ. So PQ cancels out with PQ and this will go in the numerator. So we are finally getting the answer P plus Q. So there we are done with the proof.